Hi guys, welcome back to Nunley Math. I'm Aaron Nunley. Thank you for joining me for the second video in our series of videos on polynomials. You can see today we're going to be adding and subtracting polynomials. In our previous lesson, we talked about what polynomials are, how we can describe or name polynomials, as well as how to put polynomials into standard form. Now, I'm hoping this is going to be a pretty brief video today because a lot of what we're going to do today relies on things that we've already learned or covered in other units. So this ought to make pretty good sense for you. So let's go ahead and just dive right in. Suppose I asked you to add these two polynomials together. Now you'll notice this has an x squared, an x to the first, and an x to the 0. Because x squared is the highest degree term, we would call this a quadratic. And since there are three terms, this is a quadratic trinomial. This quadratic trinomial is being added to a cubic trinomial. Cubic because x cubed is the highest degree term. Trinomial because there are three terms showing. Now what I'm going to do is I'm going to show you the long way to simplify this or to add this together. And then we're going to talk about some shortcuts we can take to make it just a little faster. By doing it the long way, we're able to see a lot of the mathematical logic or the algebraic logic that allows us to do this. But once we understand the logic, we certainly don't want to have to show 500 steps every time we're trying to work out a simple problem. So let's go ahead and dive right in. The first thing I'm going to do is I'm going to go ahead and take these subtraction signs and change them into adding the opposite. That is the definition of subtraction. Definition of subtraction says anytime you have subtraction, you can rewrite it as adding the opposite. And the reason I'm going to go ahead and do that is because now I have one long string of addition. If I have one long string of addition or one long string of multiplication, I'm able to use my commutative or my associative properties. When we have subtraction, we have to be a whole lot more careful about that. So I'm going to use my associative property that says if it's one long string of addition, it does not matter how I group or ungroup the numbers, the answers will always be the same. So I'm going to take these two trinomials and I'm going to ungroup them so that now I have a long string of 1, 2, 3, 4, 5, 6 monomials or 6 terms. Remember, the associative property says I can regroup those. And then I'm going to color code those so they're a little easier for you to track. Notice that my 3x squared and my negative 3x squared are both blue. My negative 2x is green. My x to the third or 4x to the third is purple. And my negative 4 and my 2 are kind of a burnt red or brownish red along the way. All I've done there is color code. And the reason I did that, the reason I did that is because I want to use my commutative property to rearrange this so my like terms are together. So in other words, I'm going to start rearranging with the commutative property, putting this 4x to the third first because that's the highest exponent that I see. Then I'm going to take this 3x squared and this negative 3x squared, and I'm going to write those next, followed by the negative 2x, and then followed by the minus 4 and the plus 2. Notice these are written in order by descending degree. X to the third, x squared, x to the first, and these of course have 0 x's. The commutative property says I can rearrange these however I like. And then I'm going to use the associative property to regroup the like things together. Notice the 4x to the third is all by itself, but I have two of these x squareds. So I'm going to put those in a group together. I have only this negative 2x, so I'm going to leave it alone. And then I'm going to come over here and group this negative 4 and my 2 together using the associative property. And lastly, I'm going to combine my like terms. I'm going to keep this 4x cubed. 3x squared plus negative 3x squared makes no x squareds. I have a minus 2x, and I have a negative 2. Again, that is the distributive property that allows me to combine like terms. It's an unusual application of the distributive property. Most people don't recognize it as it, but that's really what allows us to do that. And there's my final solution. Notice my final answer is a cubic 1, 2, 3 trinomial. Again, this is the long way that shows the algebraic reasoning that allows this to happen. Most of the time, you're not going to want to do that. most of the time you're going to want to just look at your addition problem and say, oh, this is a fifth degree 1, 2, 3, 4 fifth degree polynomial being added to a fourth degree 1, 2, 3 trinomial. And rather than rearranging and regrouping and ungrouping and doing all of that, what we're going to do is we're going to just realize that as long as this is all just addition and subtraction, I can rearrange, regroup, and combine all I want. In other words, I can look here and see that this is the only 9m to the fifth, and I can just write it down. Then I can see this is the only 5m to the fourth, and I can write it down. I can look and see that this is the only m to the third, so I write it down. But when I get to my m squareds, I have 6 of them here, and I have -7 of them here. I'm going to go ahead and put those together to make -1m squared. And that leaves me with my +3 and my +6, which makes a +9. Notice that I can write that as plus negatives, or I can change it back into subtraction. Either way, this is my solution. It is a fifth degree polynomial. Most people find it easier to just look at the long list and start underlining and circling and grouping things mentally rather than having to go through and write out all the commutative and associative properties. I have no problem with that, but what I do recommend is that as you're working your way through, you make some kind of markings to indicate for yourself which things you've already used. Now, I color-coded here because I have the luxury of using my computer, but if this were just a pencil and paper, I would probably go through and circle the m to the fifths, then maybe underline the m to the thirds, and maybe draw a square around the m squareds, and maybe a squiggly underneath the constants. I don't really know, and it's not really important. The important thing is that you make sure that you don't leave anything out, and also to make sure that you don't count anything twice. Keep in mind that when we're writing polynomials, we always want to write them so that the terms or monomials are in descending order of degree, which means you want your fifths before your fourths, before your thirds, before your squareds, before your constants. If there's a tie, then typically they would be arranged alphabetically, and I'll show you one of those in just a minute. Subtracting polynomials works much the same way. I would warn you though, you have to be very, very careful about this minus sign right here. Just like in our other units, this minus sign between the parentheses is a constant source of aggravation and problems for people. In fact, just like I said in other units, I'm going to recommend that you turn that minus sign into a plus -1 and then use your distributive property to pass that -1 out to everything in the second parentheses. So notice I turned this minus into plus negative. I'm going to take this -1 times a to the fourth and get -a to the fourth. I'm going to take this -1 times -4a cubed and get +4a cubed. And I'm going to take this -1 times my -3a squared and get +3a squared. After I've done this works exactly like it did when I was working with addition. Notice I have a -a to the fourth, but that's the only one I have. I have a 1a to the third and a 4a to the third. I put those together and get 5a to the third. I have -2a squareds and I have +3a squared. That's 1a squared, and that leaves me with this lone plus 4. My solution is a quartic polynomial. Again, no different than addition, except for the fact you have to deal with that minus sign first. Now, a lot of my students ignore my instruction on doing that, and when they do, a lot of times they remember to pass the negative out to some of these, but not all of them, and they end up making a lot of careless mistakes. Trust me, this is a big trouble spot. Be very, very careful there. I would suggest pausing the video and trying this next one on your own, then restarting the video to see if what you did matches what I did. I'm going to go ahead and do that. I'm going to rewrite this first expression, but I'm making that minus into plus negative. I'm going to take this negative sign and I'm going to pass it out to all three of these. That makes it a -9p squared. -1 times -5 makes plus 5p. And notice that -1 times -3 makes +3. I didn't take the time to write it out this time, but I was extra careful when dealing with it. Just like before, I'm looking for things that are in common, starting with the biggest. 5p squared and negative 9p squared is negative 4. I have negative 3p and positive 5p makes 2p. And I have a 6 and a 3 making a 9. My solution is a quadratic 1, 2, 3 terms trinomial, a quadratic trinomial. Last one again, this one's a little harder, but I would recommend that you pause the video and try it on your own. I'm going to speed through this one knowing that you guys have the ability to pause if you need to. Notice I'm taking the first expression, this first trinomial, making that minus into plus negative. I'm then going to be very careful passing this negative out to all 4 of the other terms. This is a plus 4x cubed y squared. Negative negative makes this a plus 3x squared y squared. I have a negative and a positive giving me plus negative 3xy, and a negative negative giving me a plus 5x squared. Looking for my highest degree term, I notice that I have a 5th degree term and another 5th degree term. These match exactly, so 3 of them and 4 of them make 7 of them. I'm scanning through looking for the next highest. That's this 3x squared y squared. It's the only one. I then notice that this is a 2nd degree, this is a 2nd degree, this is a 2nd degree, and this is a 2nd degree. All of those are quadratic terms. Whenever that happens, I look for alphabetical. Notice that xx alphabetically comes before xy. So I'm going to take that x squared and the 5x squareds, and I'm going to have 6 of them. And I'm going to take my negative 4xy's and my negative 3xy's, and I'm going to have negative 7 of them. That is my solution. This is a 5th degree polynomial. Hopefully that's been useful and helpful to you. Thank you so much for checking us out. As always, please make sure you give us a big old thumbs up. Make sure you ring that bell to turn on your notifications so that you receive all the new information coming from us here at Nunley Math. As always, I do wish you guys the very, very best. Take care of yourselves. Bye-bye.